Hello coders! In this video we are looking at a straightforward approach to Advent of Code 2022's Day 11. The first part of this puzzle should be approachable by anyone who has learned the basics of coding. There's only one tricky piece, and that's checking for divisibility. We're going to do this using modulus arithmetic, but don't worry if you're not familiar with modulus arithmetic. I will be covering it in this guide. I've posted a link to the puzzle in the description below this video. And if you get stuck, don't hesitate to post your questions in the comments or make a post on the Advent of Code subreddit. Tons of people there always willing to help. Of course, if you find this guide helpful, let me know by clicking that like button. And if you want to see more of these guides, be sure to subscribe. And with that, let's get into it. Hoping to catch up with the elves, you begin to make your way upriver. Suddenly, you realize your pack is much lighter than it should be. Before you can react, an item whizzes past your head. Looking about, you see a troop of monkeys have stolen your belongings and are playing keep away. To retrieve your items, you will need to be able to predict where the monkeys will throw them. Can you design an algorithm to determine where each item will be thrown? Captain Coder here with Day 11 of Advent of Code 2022, and we have been here for more days than I have fingers to show. As you heard, you're caught in an unfortunate game of monkey in the middle. Before we can continue up the river, we are going to need to beat these simians at their own game. As always, it is important to break down a problem like this so you know what the inputs and outputs will be. In this case, our inputs describe two things: the initial state of our puzzle, as well as the behavior, how the monkeys are going to act during our simulation. Let's take a look at the provided example here. So this is the example input. We have monkeys like this, so monkey 0. The first line inside of each monkey is the starting state of that monkey. This is the items that monkey has. This is represented by a list of integer values. These integers represent the amount of worry you have for that specific item. The next line on each monkey is an operation. This is how the monkey is going to update how worried you are about that item. There's one little thing sort of hidden down here below, is that every operation also has a divide by 3 after it. So we perform this operation. We take the old worry value. In this case, it would be the old worry value multiplied by 19 to get the new value. Then we're going to divide it by 3. Then we are going to inspect that new value, test to see if it's divisible by some number. Monkey 0 divides by 23. If it is divisible, they're going to throw that item to monkey 2. Otherwise, throw it to monkey 3. Each monkey has a set of items, a unique operation, a unique divisibility test, and then a monkey to throw it to if the divisibility is true or false. So, in this game of monkey in the middle, the monkeys take turns. So a monkey starts. So for example, let's go down to this input here. If we play monkey in the middle over a series of rounds, the first round with this input would look like this. Monkey 0 inspects all of the items in their bag, updating the worry value, testing the divisibility, and then throwing it to the appropriate monkey. Monkey 0 has 2 items to start, so monkey 0 is going to iterate through both of those items before monkey 1 processes their item. Therefore, monkey 0 might give monkey 1 new items, which they will inspect on their turn. So a round happens by monkey 0 executing, monkey 1 executing, monkey 2 executing, etc. until all of the monkeys have gone, and that's an entire round. So what are we trying to calculate here? What's the final output we need to do? We are going to let the monkeys play 20 rounds, and then we need to calculate the monkey business. I love this term here. We calculate the amount of monkey business that the monkeys have here. This is calculated by finding the 2 monkeys who have inspected the most items. So we're going to have to keep track of the number of items each monkey has inspected. And then at the end of 20 rounds, we find the 2 largest inspection amounts, multiply them together, and that is our monkey business. So we're asked, what is the level of monkey business after 20 rounds of stuff slinging simian shenanigans? I absolutely love that. Okay, so hopefully we have a better understanding now of what this puzzle's asking us to produce. And with that understanding, let's look at a strategy for approaching a solution. First, we need to make sure we can perform the monkey's operation. To do this, we're going to define a data type that represents an operation. Next, we're going to create a monkey type, which represents the state of a monkey. This is going to include the items they currently have, which monkeys they're going to toss things to, what operation they're going to perform, and how many times they've inspected an item. So we're going to have some statefulness happening here. We're going to keep track of the state of each monkey. Once we have these 2 data types, we can start writing some functions. The first function we're going to write is called InspectItems. This function is going to process a monkey's list, going through each item, inspecting them, applying the operation, and throwing it to the appropriate monkey. Once we have that function, we're essentially ready to solve the puzzle. We just have to write another function to parse our input into our data model. And once we've parsed it into our data model, we simply iterate over that list of monkeys once per round for a total of 20 rounds. And then at the end, we calculate the total monkey business and display it. All right, are you ready? Let's get into it. All right, so the first thing we're going to do is come up with a way to represent a monkey operation. We look at our example inputs. We see that an operation that the monkey can perform is either multiplication or addition. We take our old value and multiply it by an integer or our old value. So you can multiply the old value by itself. You can square it. We can also have old plus an integer. It's not shown here, but I'm also going to think through, we might be able to have old plus old, but we're dealing with addition and multiplication. The way I'm planning on representing this is creating a data type that's going to take in this expression here, the right side after the equals. For example, I've defined a record type here. You might use a class or a struct, but my operation accepts an expression, and it's going to be something along the lines of old plus 6, old plus old, old times 9, or old times old. So it's some expression added or multiplied by another value. Then I need to write a function called apply, which will take in the item value. This is going to be our old value, and it's going to return the result of performing this operation. So a little tip here, if we have this expression, we have 3 tokens that we're going to pull out. So we're just going to pull out those 3 tokens, evaluate them, and then perform the desired math. I've written a test here to give myself confidence that once I've finished its implementation, it's working correctly. And so I've used the examples here. So if we look at monkey 1, they have the operation old plus 6. Let's go down to monkey 1 here. And we see that their first worry level is 54. We're going to apply 54, and we're hoping that the result is 20. This is because the item worry level 20 is thrown. So old plus 6 applied to 54 should result in 20 from our example. We have another monkey that we're going to test here, old plus old. If I do 15, it's going to be 15 plus 15 divided by 3. So I should get 10 back. And I've come up with these examples here. I also have a test for my multiplication. So if I look at monkey 0, I have old times 19. And their first value is 79. And I'm expecting from my example that the value that they're going to throw is 50. If I apply 98, I should get 620. 98 becomes 620. And same with old times old. This is monkey 2. 79 is the example we have here. We're expecting to get 2080. 79, 2080, and then 60 and 1200. Go ahead and define an operation type for yourself, write an apply function that is going to take the expression of that operation and perform it on an input integer, returning the result. Be sure to give yourself a test. Run your implementation against that test to give yourself confidence. If all went well, you now are passing your test and you have confidence that your operations apply function will work the way you want it to. If you're not there yet, be sure to pause. I'm about to show my solution. Here it is. I have an apply method here as part of my operation. In this case, my apply takes in an item. This is the worry value of an item. I take the tokens of my expression. This is calculated by splitting it, so it's going to break it up into 3 components. And then I need to check what the 2 rightmost components are, so the second and third one. I always know that my first token is going to be old. And so I need to check what the other 2 tokens are. There are 4 possibilities: multiplication with old, addition with old, multiplication with an integer, and addition with an integer. So if I have multiplication with old, I square my item, divide it by 3. This is a critical part here. You gotta make sure you divide by 3. If I'm adding old, I sum it together and divide by 3. If I am multiplying just an integer, I take that token, I parse it as an integer, multiply it against my item, and divide by 3. And if I'm doing addition against an integer, I parse it in, add it together, and then divide by 3. And if I get something that isn't one of these expressions, I throw an exception stating that I couldn't perform the specified expression. Next, we need to come up with a model to represent a monkey inside of our program. If we look at our inputs here, a monkey is going to need to have a list of items it's currently holding, an operation that it's going to perform. We need to know what number it's going to be checking for divisibility when it does a test, as well as which monkey it's going to throw it to if it's true, which monkey it's going to throw it to if it's false. Also, not listed here, but if we go all the way down to the problem, at the bottom, we know that we're going to have to include how many times the monkey has inspected an item. So that's 6 properties for your item. All right, so in your language, you're gonna need to implement a monkey data type that has those 6 properties or some way to represent those 6 properties. Give it a shot. Here I am with the type I've come up with for my monkey. In C#, I am using a record type. In your language, you might be using a class or a struct, anything that your language provides for creating objects. In this case, I have the 6 properties we need, a list of integers representing the items the monkey is holding, an operation representing the item operator that it's gonna perform on each of the items, a divisor representing how it's going to do a test, a true index and a false index depending on how the divisibility turns out. And then finally, I have an inspection count. If you need to, go ahead and pause, get your data type working, and then we're going to move forward. And with our monkey data model in place, we're ready to write an InspectItems method. This method is going to operate over the items the monkey currently is holding and determine which monkeys should receive the new item. In this case, this function loops through all of the items, applies our item operation to it, checks if that number is divisible by this divisor. If it is, we add it to the monkey at index true index. And if it's not divisible by our divisor, we add it to the list that the monkey at false index has. So how do we determine whether or not it's divisible by divisor? We are going to use the remainder operator. In some languages, it's called the mod operator. In a search engine, type in how to determine remainder in Python, how to determine remainder in C++, whatever language you're using. But the way you're going to use it is you're going to check the remainder given the divisor. And if the remainder is 0, that means that it's perfectly divisible by our divisor. To give myself confidence that it's working, I've written a test here in my monkey test. Doing test inspect items, I've created each of the monkeys in our example. So if I scroll all the way up here, I've created a model for monkey 0, 1, 2, 3 based on this input. So this is what they should look like. I create a list called friends, which contains all of my monkeys. Then I'm going to follow my example, monkey0.inspectItems. The results of calling this should be that I throw the item 500 to monkey 3 and the item 620 to monkey 3. So I've gone ahead, checked that after I have finished my inspect items, I have no items. Monkey 0 has thrown its items, so it has no items left. It has an inspection count of 2 because it inspected 2 items. And that monkey 3 now has 74, 500, and 620 because it originally started with 74 and we threw it 500 and 620. So I've gone through the entire example and written a test. That way, when I run it, I'll have confidence that my inspect items method is working for each of the steps. This is essentially simulating one full round. All right, go ahead, write yourself a test, implement your inspect items function or method, run it against your test, give yourself confidence that it's going to work. Good luck. I'm happy. I hope you're also happy. My test is passing, giving me confidence that my implementation will work for a full input. If yours is not passing just yet, go ahead and pause, see if you can get it working. But here is my solution. So my inspect items method is taking in my list of monkey friends. I'm going to iterate through all of the items in my monkey's inventory, essentially, all the items the monkey is carrying. I loop through them. I calculate the new value by applying my item operation to it. Then I need to check divisibility. I use the remainder operator to get the remainder of new val divided by the divisor. And if it's 0, it means it was divisible. If it's divisible, I take my true index, look up my friend, look up the monkey here, and I add it to their items list. If it's not divisible, I do the same thing with the false index. So each time I inspect an item, I increment my inspection count. Finally, once I'm done looping through all of these, I go ahead and clear that list out to represent that I've thrown all of the items. And we're almost ready to solve the puzzle. We just have to get our input parsed into our data model. So I have written a couple functions here. The first one is ParseAll. This is going to take in the entire input and give us back a list of our monkeys in the starting state. To help with that, I'm going to recommend writing a few helpers. You can go ahead and write ParseAll top to bottom if you want to go through that pain. But I'm going to highly recommend breaking it down into a couple smaller steps. Parse is going to take in a single set of monkey information, just a single set of monkey information like this, and give you back a monkey with just that information. To do this, I have three helpers really. Parse start items, which is going to parse just this row. So it's going to take just this row of input and give us back these numbers in a list of integers. We're going to have a parse operation, which is going to take in this row and it's going to give us back an operation that has this expression passed in. And then I have a third one, parse last int. We recognize that in the next 3 rows, the value that we're interested in getting happens to be the last token. So I am going to write my ParseAll using these 4 helpers, my parse, and then the parse is going to use the parse start items, parse operations, and parse last int. And of course, you know me, I've written some tests here. Let's take a look at what those are. I have taken that first monkey here, monkey 0, and I have passed it in to my monkey.parse method. This is going to tell me whether or not these monkeys match. So the list I'm expecting to get back is 7998. So I check that my expected list is equal to my monkey 0's items. I check that the operations match, the divisor is correct, the true index correct, and the false index is correct. Then for my test all, I take that whole input, the entire example input, build up some tests here, do a ParseAll, and then I check that each of the properties on each monkey matches across. Why don't you go ahead, write yourself a test, write your methods, run it against your tests. Hopefully it'll pass. If it doesn't, keep iterating till it does. Good luck. Ideally, your tests are now passing. You have confidence that your implementation is working. If you're not quite there yet, go ahead and pause. I'm about to show my solution. Here I am in my monkey record. I have a ParseAll function that accepts the full input. I create an empty list that I'm going to populate. I take my input and I split it on 2 blank lines. So I'm looking for these blank lines. So I'm going to break this up so that I have strings that are just this chunk, and this chunk. So I identified that by the blank line. So I do new line. That's where I'm splitting it. Then I loop through each one of my monkey inputs, passing it off to parse, which is going to give me back a single monkey. I add it to my friends, and then I return my full list. So let's look at the inner components here. Parse. To parse a single monkey, I split it by new lines. So now I have rows of input. I have a function that parses the items from that row. So I pass row 1 to parse items. I pass row 2 to parse operation. Row 3, 4, and 5, I pass to parse last int. And then I pass those to the constructor for my monkey. For parse items, we can break that down. We are going to first split on this colon. That's going to give us a left and right side. Then we're going to have our list on the right side. Then we're going to split on the comma and then loop through each one of those, parsing them in. So here we are, we split on the colon. Then we have our item strings. That happens to be the right token. We split that on the comma. We create a list of integers. We loop through that, adding each item to our list, and then finally returning all of the items. Parse operation, I recognize that we can split on this equal. So we split on the equal. We take the right side. So we split on the equal. We take the right side of that split. We trim it to get rid of the extra white space, and then we create a new operation. Lastly, for our parse last int, I take my row, I split it into tokens, and then I get the last element. So in C#, this gets me the last element. And that is my implementation for parsing in my inputs. With that in place, we are ready to solve this puzzle. We're going to take our input. We're going to parse it into a list of monkeys. We're going to loop 20 times. We're going to do 20 rounds. Each time we need to perform the inspect items on each monkey. Once we've done that 20 times, we need to find the 2 monkeys with the highest inspection count. To calculate the monkey business, we multiply the 2 highest inspection counts together, and we report the total monkey business. Go ahead, give it a shot. Good luck. If all's gone well, you now have a program telling you the total monkey business for your puzzle. I've taken the example input from our puzzle here. And I'm seeing that the total monkey business after 20 rounds is 10,605, which is what I was hoping it would be. If yours is not producing 10,605, go ahead and pause, see if you can get it working. Here is my solution. I start by parsing in all of my monkeys into a list. I'm calling my list friends. I loop 20 times, once for each round. During each round, I loop through each monkey, goes in order, calling InspectItems on the friends list. After the 20 rounds, I sort my list such that it is in descending order. The biggest numbers will appear at the beginning, and my monkey business becomes the first monkey's inspection count multiplied by the second monkey's inspection count, and then I report that value. All that's left is to download my full input, run my program, get my solution, pass it in, and if we're lucky, get a beautiful gold star. Hopefully at this point you've submitted your solution and received a beautiful gold star. I hope you found this video helpful. If you did, let me know. Click that like button. If you want to see more Advent of Code guides, click subscribe so you'll be notified when they're uploaded. And as always, have a beautiful day. Keep on coding, keep on growing, and you're welcome back anytime.